Assalamu alaikum students. So today we are going to talk about dimensioning. You are already familiar with the dimensioning, that how it's done. You have done it in your labs and you are familiar that in drawing, dimensioning is used to actually give the information about the size of an object or the different features that are related to an object that is about to be manufactured. So in today's lecture, we are going to cover that what is dimensioning, the information that we are going to get from dimensioning, what are the basic terminologies, and the use of basic terminologies along with the recommended practices, that how are you going to dimension your drawings. So first we are going to talk about the definition, and as you can see, dimensioning is the process of specifying parts of information by use of figures, symbols and notes. And this information are such as the size and locations of feature, the material type, the number of features required, the kind of surface finish, what type of manufacturing process that is going to be required, and this size and geometric tolerances. We are going to talk about tolerances in a separate lecture, but I will give you just an idea in the coming slide. So the basic terminologies are given in numbered form here, and one is the dimension. That what is a dimension? Dimension is basically the numerical value that defines the size, shape, location, geometric characteristics of a feature. That feature can be anything, that can be an arc, that can be a circle, or a hole, that can be anything. Then what is basic dimensions? Basic dimensions are actually enclosed in a box that is also a numerical value defining the theoretically exact size, location, profile or orientation of a feature identified by enclosing the dimension in a box. Then there is another type of dimension, that is the reference dimension. Reference dimension are not basically used for manufacturing a part, but they are used to give an added information about your object that is about to be manufactured. So it is a numerical value enclosed in parentheses, providing for information only and not directly used in fabrication of the part. Then there is dimension line. You are familiar that what is dimension line is used for, and it is a thin solid line that shows the extent and the direction of your dimensions. Then there are arrows. Arrows are symbols placed at the end of dimension lines or leader lines to show the limits of the dimension, leaders and cutting plane lines. Then the extension line, you are already familiar with extension lines, and it is a thin solid perpendicular line to a dimension line indicated which feature is associated with the dimension. It actually shows the feature that is being dimensioned. Then we will be talking about the visible gap, that there should be a visible gap between the extension line and the object, and it should be about 1.5 mm. Then leader line, you are already familiar with the leader line. Leader line is used to dimension circle, arcs or give notes or other symbols on your object. Then there are limits of size. Limits of size, the largest acceptable size and the minimum acceptable size of a feature. There are two conditions, that is the maximum material condition and the least material condition. We will be talking about that in the coming slides, so I will skip it right now. Then there are also plus and minus signs. I will talk about that also in the coming slide. And again, there are diameter symbol, and this is the radius symbol. Tolerances is the amount that a particular dimension is allowed to vary. So the tolerances, the plus minus sign and the limits of size, they are basically the same thing, and it actually explains the same phenomena. So I will be discussing the tolerances, the limits of size and the plus and minus signs in the coming slide. And then there are datums. Datums are basically the reference points that are used for dimensioning your object for tabular dimensioning. So let's see what a datum is, and then we will move further to explain these different terminologies and talk about tolerances and limits of size and plus minus signs. So this is an object that is being dimensioned, and as you can see, there are two types of dimensioning. One is the vertical dimensioning right here, and the other is horizontal dimensioning. And that dimensioning, if you look at the horizontal dimensions, that is done from this edge. That is done from this edge. So this edge is basically the datum for these horizontal dimensions. As you can see, this is the datum surface for horizontal dimension x. This datum surface is the reference point for all these dimensions, as you can see right here. Then you can see vertical dimensions, and for vertical dimension, this is the datum surface. This is the datum surface from which these features, different features. For example, this is features, this 30 shows the center of this circle from this edge, and this 45 shows the center of this circle from this datum surface, and then this center from this datum surface. And similarly, these vertical dimensions are also showing the same thing. We already discussed that we need two dimensions to actually place a circle on an object, or manufacture a hole in an object. So for that purpose, we need two type of dimensioning. One will be the horizontal dimensioning, and one will be the vertical dimension to exactly position a hole correctly at its place. So for that purpose, we will need some datum surface, and right here for the horizontal dimension, this is the datum surface, and for vertical dimensions, this is the datum surface, as you can see in the figure. Then these are the different terminologies that we talked about. As you can see, the dimension line, the dimension right here, the extension line, then this is the arrows and the basic dimensions that are actually used to manufacture an object. Then there should be a visible gap between the extension line and the object. Then again the diameter symbol, the leader line, the radius symbol, the reference dimensions that are not actually going to be used to manufacture an object, but it gives you an added information of your object. Then there comes the notes that are being added, and here the note is all format plus 0.0 plus 0.05 unless otherwise noted. So what are the plus and minus dimensioning? What are the limits that are being shown here? What are the two dimensions that are actually presenting the same feature, or providing of info about the same feature, but there are two dimensions? Why we use two dimensions? Actually, our machines that we use for manufacturing are not that perfect to manufacture an object exactly to a same size. For example, let's say that this is a rectangular block, and the dimension, let's say the width of that rectangular block is 5. So if I choose, let's say 5 inches, and if I choose it to be 5 inches, then we do not have such precise machinery to actually manufacture this object exactly to 5 inches. So what we do, we select two limits for this 5 inches. That will be the acceptable range that will be used to actually maintain the width of that object. For example, I cannot manufacture an object exactly to the 5-inch width. So what I will do, I will place some limits that the allowable limit is that between 5.1 or between, that is 4.9. So right here, these are the limits of sizes, that is the 5-inch width. So I can vary from this 5-inch plus 0.1, and I can vary from it minus 0.1. So these are the limits, and this plus minus actually are the limits of these sizes, and that's why you can see that this is the limits of the sizes. So I can actually write this 5 dimension right here again when I apply these limits, and I can write this as 5.1 and 4.9. So these are the limits of sizes for this width of this rectangular block. Then I can also write it as such, like this, that if this is my rectangular block and I have to dimension it, I have to dimension it like this. Let's say this is the actual 5-inch width, and then I also add the limits, that is plus 0.1 minus 0.1, just like here, just like as you see here that the actual dimension is shown, but we can vary from this actual dimension plus 0.32 and minus 0.10. So again, we do not have such machinery, such precise machinery that can exactly manufacture an object to the dimensions that are specified. So what we do, we actually give limits to our dimension, we apply limits to the dimension, we apply a range of dimensions. For example, in this case, we use that the width of the object can vary from 4.9 and 5.1. So everything that is between 4.9 and 5.1 inches will be acceptable for this rectangular block. Other than that, that will not be acceptable. So it gives us a little room for error, that if our machine is not that precise, we can actually use the this tolerance, this limits of sizes, or these plus minus dimensioning to actually manufacture a part within our allowable limits. Then what are the dimensioning components? And you are already familiar with these terms, that is the extension line, the dimension lines with the arrowheads, then the leader lines, dimensioning figures, and these figures includes the local notes and the general notes. Let's look at them one by one and we will explain them in the coming slides. And you are already familiar that we draw extension line with the 4H pencil and these with the 2H pencil. So extension line, as you already know, indicate the location of an object's feature that are to be dimensioned. So if this is our object and these are the extension lines, as you can see, they show the different features that are going to be dimensioned. This is showing the width of this object. Then this dimension will show the center of this circle from this edge. So this will be our datum. This will be our datum surface. Then this dimension will show the center to center distance between these two holes, and then the position of this hole from this edge right here. So these are the different type of dimensioning that we specify with the help of the extension lines. And of course there is this feature which will also be specified with the help of the extension line. Then we will put the dimension lines between these extension lines to specify that what are we actually showing, and it indicates the direction and the extent of dimensions and inscribe the dimension figures. So these are the dimensions line that will be added between these extension lines to actually show the features that we are going to dimensions on this object, and then we will write the dimensions. So you can see, you are already familiar with this, that it actually shows the dimensions of different features. The arrowheads are used, and there are different guidelines. The arrowheads that are used in the dimension lines, they can be filled, they can be closed, they can be open. These are again according to different standards, and the text height again is 3 mm that are going to be used for dimensions. And you can also represent a dimension like this. You can also put the dimension lines outside the extension lines, you can place them inside the dimension line, and similarly in here. So these are the different features of an arrowhead that are going to be used for the dimensioning. And if this is the width of the arrowhead, then the length of the arrowhead will be 3 times the width. So these are different standards, and these are the ANSI standards that are going to be used for the arrowheads for dimension lines. Then there is also another type of line that you are familiar with, and that is the leader line. And leader lines, as you are familiar with, are used to actually represent the dimensions of the holes or the arcs that are present in our feature, as you can see. And there also, we also add notes to the leader lines. As you can see that the 10 drill actually shows the dia of the hole. By drill, this is also means that this also shows the machining operations, but it also represents the diameter of this hole. And then there are 2 holes, as you can see. So we do not put dimensions on each feature separately, but we actually put a single note on a single feature, and we specify it whether for how many features we are representing that dimension. For example, this 10 drill is applicable for these 2 holes. So this hole is also of diameter 10. Then the radius 16, this arc 16. So then these are the extension lines, and extension line should have a visible gap from the object that is drawn near. As you can see, these are the extension line, and there are these gaps that we leave because the outline or the object line actually represents the boundary of your object. So there should be this visible gap so that you cannot confuse it for a feature of an object. Then these are the visible gaps whenever you dimension your object. Then extend the extension line beyond the last dimension line, that is 1 or 2 mm. That for example, what is meant by that, that if you want to, you should draw your dimension line as such that there should be some extension line left beyond, that should be of 1 or 2 mm. So this is what is meant by this. These are the good practices that are used in dimensioning, and we will use them as such. These are the recommended practices, and these are the common mistakes that people do by placing their extension lines or dimension lines. As you can see, the extension lines are too far away from this feature, so it does not actually properly represent the dimensions of this feature. And here, as you can see, the extension lines are not properly extended beyond this dimension line. So these are the common mistakes that people make. So extension lines do not break the lines as they cross the object line. For example, if you are going to dimension this feature, then there should be no break. There should be no break. The extension line should be continuous. Similarly, for this feature, if you are showing the center of the hole from an edge, then there should be no break when you are drawing the extension line. And this is the common mistake that people make. This now here is that there is a visible gap. Then again, dimension line should not be spaced too close to each other and to the view. What is meant by that? That if these are the extension lines, then leave a space of at least 2 times the letter height. That if the space, this is the space that they are talking about, the dimensions should not be placed too close to this object. There should be a space of at least 2 times the letter height. 2 times the letter height means that that should be 6 mm space. This should also be 6 millimeters of space. Similarly, right here, if you are again dimensioning the same feature, another feature on the same object, then you should leave at least 3 mm of space. Leave a space at least 1 time of a letter height when again you are dimensioning something, a feature above above a feature that is already being dimensioned. Then again, the height of the figure is suggested at 2.5 to 3 mm. We have already discussed that, and place the number at about 1 mm above the dimension line in between extension line. What is meant by that? You can see that from the mistake they will place the dimensions right below this dimension. So this is not recommended. You should actually place this dimension right over here, as you can see here, that it should not be confused with any other dimension, but it should be clear. Okay, when there is not enough space for figures or else put outside either of the extension line. For example, if this is our arrow and not enough space to put the dimension in here, so what should we do? We should actually place the arrows outside the extension line, or we should actually place the dimension outside the extension line. And if there is not enough space for the arrows, then what you should do, you should actually place the arrows outside the extension line as such. So the dimension figures according to Japanese International Standard and ISO standards adopt the unit of the land dimensions in millimeters without specifying a unit mm. We have already discussed that we do not specify the units on the drawings, and angular dimension in degree with a symbol. This degree symbol is used, placed behind the figures, and if necessary, minutes and seconds may be used. Then local nodes place the nodes near the feature which they apply and should be placed outside the view and always read horizontally. So for example, what is meant by that, that if you are going to represent the diameter of this hole, so we should not align this with this line, but we should write this horizontally as it is written. There should be also a 10 mm space between this leader line and the edge of this object, and the common mistake is this one, that we place the node, that is the 10 drill, too far away and we actually align it vertically. So this is the common mistake that people make, which should be avoided. So the basic concept is dimension is accomplished by adding size and location information necessary to manufacture the object. And this information have to be clear, complete, facilitate the manufacturing method and the measurement method. For example, if this is our rectangular block that is to be designed, that is already designed, and there are two holes, what we should do, how should we dimension it? To manufacture this part, we need to know two things. One is the width, depth and thickness of this rectangular block, that is the length, width and thickness, and then the diameter and the depth of the hole. So the size dimensions are represented right here with the S. And the location dimension, the dimensions that denote the location, are represented by the alphabet L. So these are the size dimensions. As you already see, they represent the size of the different features of this block. And then these are the dimensions that will show the location of this hole on this feature. So there are two types of dimensioning you can see from here. One is the size dimensioning and one is the location dimensions. These are the location dimension. Then there are angles. To dimension an angle, use circular dimension line having certain at a vertex of the angle. For example, if this is and this is the circular dimension line that is be used to represent this angle, then again this is the circular dimension line that is going to be used to represent this angle. Then again, if there is no line, then we should draw an extension line to actually represent an angle. These are the common mistakes, that we actually draw it too oblique. We draw the dimension line too oblique like this. We should draw it a little less oblique like this. Then fillets and rounds, you are already familiar with this term. Fillets are used to actually round a certain sharp edge and give radius of a typical fillet only by using local node, and local nodes are represented by the leader line. If all fillets and rounds are uniform in size, dimension may be omitted, but it is necessary to add the note that all fillets and rounds are radius of this. For example, here only one edge is dimensioned. One edge is dimensioned only, that it is of radius 6.5. And a note is placed beneath it that all fillets and rounds are of radius 6.5. It means that this radius, and all the radiuses, when you see them, they are all of radius 6.5. There is no need to dimension them separately, but a separate note can do that. And also you can also represent the radius by this, and again all fillets and rounds are of radius 6.5 unless otherwise specified. What does that mean? Because this radius right here is 12, but other than that all the radiuses, the remaining, are of radius 6.5. Then if you are talking about cylinder, then we should actually show the diameter of this cylinder in the longitudinal view. Longitudinal view is the one which shows the length of the cylinder. As you can see, this is the pictorial view. So when we draw the side view, it will actually give us the diameter of this. It will actually show us the length of this cylinder, and then we will place the diameter symbol to actually show the diameter of the different features on the cylindrical feature. Then holes size dimensions are the diameter and depth of the hole. These are the two features of a hole that we are interested in. One is the diameter and the other is the depth. and location dimension must be located from its central line and should be given in the circular view. Then again, we use leader line and local node to specify the diameter and the hole depth. And for example, if this is the front view and top view of a certain hole, then we should place the diameter symbol with the dimension. This actually represents a certain type of number. We can also represent this as such by writing through with it. It means that this is the through hole, and then we can also represent it as such, that is a drill, or if it is a through drill. So these are different representation of different types of holes. Then for large holes, use extension and dimension lines. This is what we use. We can use extension and dimension lines also for large holes. We can use the diametral dimension lines, which is drawn inside the hole, and we can also use the leader line. Chamfer is also used to actually make a sharp edge slant, and this is a chamfering, and a chamfer needs one linear length and one angle. It can also be represented with a length and an angle. If the length is 45 degree, then we actually draw alphabet C with it, and the letter S actually represents this length. Or we can also draw chamfer by specifying two lengths. So one will be this length right here, and the other will be this length. If these two lengths are known, we can actually chamfer a sharp edge. Then what we should do, we should dimension according to the manufacturing methods used. For example, if these are the two holes, so the manufacturing method that is going to be used is drilling. That we will use drilling to actually manufacture two holes in this block. So what we will do, we will need this information, the radius of this edge, the diameter of the hole, and again the width of this slab, and this is the manufacturing method that we are going to use. So what we are going to need, we are going to need the center to center distance also when we are going to manufacture this block. So this is the one hole that's drilled, and then how much distance is required to move this drill bit and actually make the second hole. So this is what we should do. We should actually dimension objects according to the manufacturing methods that are going to be used. So this is the center to center distance that is crucial in this case. So these are the different practices and the different recommended practices and the different terminologies that are going to be used in dimensioning. I will show you some other example in class when we physically take the question answer session. So hopefully that was clear so far, and see you in the class for the question answer session.